Consider hydraulic lift in general. Hydraulic lift is one of several forms of artificial lift for the extraction of hydrocarbons from deep beneath the Earth's surface. Hydraulic lift differs from most other forms in that the connection between surface equipment and the subsurface pump is not made either mechanically or electrically, but hydraulically in the form of pressurized power fluid. A hydraulic lift system is comprised of four major components: the power fluid surface pump package, including the prime mover, the wellhead control assembly, the subsurface jet pump and its ancillary equipment, and the surface separation package, which separates well production fluid from the power fluid, either oil or water, which may also include a method of cleaning the returning power fluid. The power fluid surface pump is normally a single-acting multiplex plunger pump powered by either an electric motor or a natural gas or diesel engine. The power pump usually has the capability of pumping against 5,000 psi. The power system is activated from a remote control panel. As the primed pump starts up, power fluid is drawn from a horizontal reservoir vessel, pressured up through the power pump, wellhead, and downhole through the tubing to the subsurface jet pump. The jet pump, featuring the Venturi principle, draws the produced fluid across the nozzle and throat while converting high pressure to fluid lift, and returns both the produced fluid along with the used power fluid up the well annulus to the surface. The mixed fluids are then routed to the accumulator vessel and then through the cyclone. The cyclones filter out heavy materials such as sand, sludge, and paraffin. Filtering and cleaning through the cyclones and horizontal reservoir vessel minimizes maintenance on the pump system. Hydraulic lift, then, is simply defined as a system which requires two pumps, one on the surface which acts as a power pump or fluid motor, and one subsurface that is either a jet pump or, alternatively, a positive displacement double-acting piston pump. The principal benefits of oil well hydraulics jet pump are: it functions at practically unlimited depths and well deviations relative to other types of artificial lift, has high tolerance to either entrained gases or solids, and has no moving pump parts within the jet pump. Reviewing the factors to be considered in selecting the right system, each well has its own distinguishing characteristics: depth, completion, gas-oil ratio, specific gravity, water cut, temperature, and so forth. With any form of artificial lift, particular attention must be paid to these well characteristics to select the correct pump to produce the well most efficiently. Hydraulic lift systems can pump any producing oil well, but some wells much more effectively than others. Once the true well characteristics are established and the determination is made to use the jet pump, we make certain calculations by computer analysis for the correct selection of the size of the jet pump nozzle and throat, as well as for the surface equipment. This computer analysis determines an appropriate PI, productivity index curve. There's no precise point on this curve with respect to the amount of power fluid provided by the surface power pump. However, a pressure controller or bypass pressure control valve installed in the discharge, the outlet, of the power fluid pump allows for both the pressure and the volume to the jet pump to be set for the most efficient jet pump performance. This PI curve will also indicate the maximum production allowable for the selected nozzle and throat combination to the limit where cavitation occurs. Producing marginally below this point within the range of the power fluid requirements will yield the maximum desired production rate. Looking more closely at how the jet pump operates. As well characteristics change, the jet pump can accommodate numerous combinations of nozzle and throat variations of diameter openings for the most efficient operation. The Venturi principle operates most efficiently when the correct velocity in the nozzle is achieved across the optimum opening in the throat. The high velocity of the power fluid passing through the smaller hole in the nozzle creates a pressure differential when entering the larger orifice in the throat, thereby allowing the production fluid under high head to be drawn into the commingling action of the throat. The production fluid gains momentum as the power fluid loses velocity through the throat, and upon entering the diffuser, this action transfer is converted to lift, moving the produced fluid combined with the used power fluid up the well annulus to the surface. Greater well depths require higher pump intake pressures for efficient production. The production fluid must have sufficient hydrostatic head to push this fluid into the commingling action of nozzle to throat. The greater this head, the more efficient the jet pump, allowing for a larger sizing of the throat and nozzle combination, resulting in greater production with less driving horsepower. Installation and retrieval of the jet pump is quite simple. When the well is completed and artificial lift becomes beneficial, installation of the subsurface pump can be made hydraulically by circulating to bottom or, if necessary, with a wireline unit. A jet pump assembly is normally located in a pump cavity or bottom hole assembly with a packer below, which is adapted to the well completion. At the bottom of the pump cavity is a standing valve or check valve that allows the jet pump assembly to be hydraulically retrieved by recirculating to the wellhead. The wellhead control assembly facilitates the reverse flow of the power fluid in order to lift the jet pump assembly from the pump cavity to the surface. A catcher is installed in the wellhead assembly to retain the jet pump when it reaches the surface. The jet pump, readily extracted from the wellhead assembly, can be repaired on site or, if necessary, returned to the shop for overhaul. Typical repairs involve replacing the carbide nozzle and throat along with O-ring seals, which normally can be installed at the well site. Having demonstrated the advantages of the subsurface jet pump as part of a cost-effective hydraulic lift system, let's review the benefits. It does not have any moving parts and is virtually maintenance-free. It performs at practically unlimited depths and well bore deviations relative to other types of artificial lift. Its performance is not entirely limited by either entrained gases or solids in the produced fluid. Correctly applied, it ensures greater production for less input driving horsepower. It is readily installed and retrieved hydraulically by circulating into and out of its bottom hole assembly or by wireline, and is easily serviced and repaired on-site or, if necessary, in the shop. Oil well hydraulic subsurface jet pump is simply applied, readily installed, and easily serviced. Oil well hydraulics can engineer and deliver the hydraulic lift system that meets your specific well conditions and requirements. Anywhere in the world, oil is produced.